Somewhere in this galaxy, there is a planet that makes Earth look like a mistake. Not a small mistake, not a rounding error, a catastrophic, embarrassing, almost laughable mistake. A planet so alive, so overflowing with complexity and color and chaos, that if you stood on its surface for just 30 seconds, you would never be able to look at Earth the same way again. And the terrifying part? It probably exists. Right now, orbiting a quiet star in a calm corner of the Milky Way, teeming with hundreds of millions of species, civilizations maybe, oceans that never go dark, skies so thick with life they look like a living ceiling. And here we are, on a planet that is by almost every measurable standard mid. Let that land for a second. Earth, the only home humanity has ever known, is not special. It is not optimized. It is not even close to the best version of what a living world can be. It is a compromise, a cosmic accident that happened to work out just barely well enough to produce us. But hidden in our galaxy's data, in the mathematics of planetary science and stellar physics, is the blueprint for something so much better. Scientists call them superhabitable worlds, and when you build one from scratch, using everything we know about life and planets and stars, what you get is something that does not just surpass Earth, it humiliates it. This is Hestia, and this is why Earth, by comparison, kind of sucks. Let's start with the most fundamental failure of our world, the star it orbits. Our sun feels permanent, warm, safe. It rises every morning. It has done so for 4.5 billion years. It feels like it will do so forever. It will not. Our sun is already halfway through its life, and as it ages, it gets hotter. Slowly, relentlessly, catastrophically hotter. In about 1 billion years, Earth's oceans will begin to boil. In 2 billion, the surface will be uninhabitable. The entire window for complex life on this planet is already more than halfway closed. We are living in the narrowing end of Earth's golden era, and almost nothing alive right now will ever know it happened. But that is not the scary part. The scary part is that our sun is not even a particularly good star for life to begin with. It burns too hot. It fluctuates. Its habitable zone is narrow. And at 10 billion years, it is gone before most forms of complex life would even have a chance to emerge. Hestia's star is different. Smaller, cooler, orange, not yellow. The kind of star astronomers call a K-type dwarf, and this seemingly minor difference changes everything. Hestia's star will burn for 70 billion years. 70 billion. Our entire universe is only 13.8 billion years old. Hestia's star will outlive the current age of the cosmos multiple times over. It will still be burning when everything we currently know as ancient becomes young by comparison. It radiates steadily, calmly, with almost none of the violent radiation spikes that young stars use to sterilize their planets. It gives life not just a window, but an eternity. And life, given enough time, does extraordinary things. Now look up. Because here is where Hestia leaves Earth so far behind that comparison becomes almost cruel. Hestia's atmosphere is thicker than ours, about 40% more pressure at the surface, and more oxygen. The kind of air density that changes the rules of physics in ways that feel almost like magic. On Earth, flight is expensive, energy intensive. A hard-won evolutionary trick that only a handful of lineages have cracked: birds, bats, insects. The atmosphere is thin enough that staying aloft requires constant, costly effort. This is why Earth's skies, despite being beautiful, are relatively sparse. Hestia's sky is not sparse. In dense air, flight becomes cheap. You need smaller wings, less energy, less evolutionary commitment, and over billions of years, that means thousands of separate lineages independently discovered flight. The sky above Hestia isn't just occupied, it's a full ecosystem, a vertical biosphere stacked above the surface. Creatures that never touch the ground, predators and prey in 3 dimensions, sky whales the size of stadiums, drifting through clouds, swallowing swarms of flying creatures by the millions without changing their expression. Earth has birds. Hestia has an entire second world above the first. And the oceans. Earth's oceans are mostly darkness. Most of the ocean floor sits below 200 meters, beyond the reach of sunlight, in a permanent, lightless cold. 90% of marine species live in the thin, sunlit layer near the surface. The deep ocean, most of the ocean, is a near desert. Beautiful, yes, but nearly empty. Hestia's oceans are shallow by design. Continental shelves dominate. Almost no part of the ocean floor lies beyond the sunlit zone. The entire seafloor is alive. Coral megacities stretching thousands of kilometers. Kelp forests the size of continents. A marine world where sunlight reaches everywhere and life has taken advantage of every single centimeter. Earth hosts roughly 9 million complex species. Scientists estimate that with Hestia's conditions, the star, the size, the layout, the temperature, the atmosphere, the oceans, the number could climb into the hundreds of millions of species. Species so strange, so specialized, so deeply adapted to specific niches that they would seem like aliens to any biologist from Earth. And some of those species, given enough time and evolutionary pressure, might become something more. Intelligent. And here's where the thought stops being science and becomes something else entirely. Imagine a planet that has generated not one, but multiple independent lines of intelligence. Separate civilizations arising on isolated island chains, developing language and culture and technology without ever knowing the others existed. Until, one day, they do. What would those civilizations think of the universe, of life, of each other? Would a species that evolved in a world bursting with hundreds of millions of other creatures see the cosmos differently than we do? Would they be more careful, more humble? Would they look at the stars with wonder, or would they already feel so overwhelmed by the richness of their own world that space felt almost irrelevant? And then, what if they look back? Now, let's talk about the planet itself, because this is where Earth's inadequacy becomes almost personal. Earth is the right size for life, but it's not the best size. Hestia is bigger, 30% wider, 70% more surface area, nearly twice the mass, more land, more ocean, more coastline, more everything, more gravity too, sure. You'd feel about 20% heavier walking on it, but your body would adapt, and in exchange, you'd inherit a world with a thicker atmosphere, a stronger magnetic field, deeper geological stability, and volcanic systems that release nutrients in slow, sustainable pulses rather than catastrophic bursts. Earth's geology is functional. Hestia's is perfect. And then there's the layout. Look at Earth from space. Really look at it. Enormous chunks of continent jammed together in the middle of nowhere. Central Asia, Central Africa, the American Midwest. Vast stretches of land so far from the ocean that barely anything survives there. Deserts, frozen wastelands, dead zones measuring thousands of kilometers across. Earth wastes most of its land on hostile terrain. Hestia doesn't make that mistake. Hestia is an archipelago world. Dozens of medium-sized continents, millions of islands, every single piece of land within reach of the ocean. No deserts, no frozen polar wastelands. Coastlines 45 times longer than Earth's, stretching across the globe like an endless border between one living world and another. And coastlines are where life explodes, where land meets sea, nutrients stack up. Energy concentrates, competition intensifies, evolution accelerates. On Earth, coastal zones cover just 7% of the ocean surface, but they house more than half of all marine species. Hestia has 45 times the coastline. You do the math. You feel what that means. But wait, it gets better. And by better, I mean worse for Earth's ego. Hestia is 5 degrees warmer than Earth. On the surface, that sounds mild, uncomfortable maybe. But that's because you're thinking about it wrong. That 5-degree difference eliminates cold zones. It removes seasonal death cycles across huge swaths of the planet. It makes the entire surface feel like Earth's tropical rainforests, which, for the record, contain more biomass and more species than every other terrestrial biome combined. Hestia isn't just tropical in a few places. Hestia is entirely tropical, pole to pole, shore to mountain. Every corner of the planet is running at maximum biological capacity, all the time. Millions of unique habitats, hundreds of millions of species filling every conceivable niche. Creatures so specialized to their exact corner of the world that they could exist nowhere else. Life stacked on life, stacked on life, in layers of complexity that Earth's ecosystems would struggle to even conceptualize. And the plants aren't even green. Because Hestia's orange star emits different light, Hestia's vegetation has evolved to capture it more efficiently. The forests are dark, deep red, near black, like something out of a fever dream. Like a world that went in a completely different direction and never looked back. What would they see? A pale blue dot, yes, but also ice caps, deserts, barren continents, hostile winters, thin air, a narrow strip of habitable coastline clinging to the edges of mostly useless terrain. 9 million species on a planet that could have supported so many more. They might feel sorry for us. And the worst part, the part that should keep you quietly awake tonight, is this. We built Hestia from real science. Every parameter is based on what we actually know about planetary habitability, stellar physics, atmospheric dynamics, evolutionary pressure, and ecological capacity. We didn't invent anything. We just chose the right version of everything. And Hestia, or something very much like her, could exist. Not as a thought experiment, not as a metaphor. As an actual planet, orbiting an actual star. Somewhere in the 100 billion star systems of our galaxy. Right now. Alive in ways we can barely imagine. We have never looked at a planet and confirmed it was super habitable. But we also haven't looked very hard. The galaxy is 400 billion stars wide. Most of those stars are orange dwarfs. Many of them have planets. And the mathematics of probability in a universe this vast doesn't whisper the possibility of another Hestia. It screams it. So the next time you look at Earth from a photograph, from orbit, from the wonder-filled perspective of someone who loves this planet, hold that love. It's real. It's valid. But know this. Somewhere, on a world we haven't found yet, a creature that has never heard of Earth is standing under a sky full of flying giants, looking out across an ocean that never goes dark, breathing air thick with the sound of a billion species that have no idea we exist. And they are home. While we are just beginning to understand how small ours really is. And if Hestia isn't the strangest thing hiding in this galaxy, if super-habitable worlds are just the beginning of what's out there, then the real question isn't why Earth sucks compared to Hestia. The real question is, what else are we not seeing?